Hi. Now, for this question, we're given that x equals a half is a root of the equation 2x cubed minus 9x squared plus kx minus 13 equals 0, where k is any real number. And we've got to find, in part A, the value of k for 3 marks, and then go on in part B to find the other two roots of the equation for 4 marks. So if you'd like to have a go at this, I'll just give you a moment then to pause the video. Okay, welcome back then if you had a go, and again you can fast forward if you just want to get an overview of the video, or I'll take you slowly through the answers. So we've got then to get the value of k. We know that x equals a half, so it should satisfy this equation. So all we've got to do is substitute a half in for x and solve it for k. So we're going to have 2 times a half cubed minus 9 times a half squared, and then plus k times a half, and then minus 13, and that equals 0. And if you work this out, you're going to find that you get minus 15 plus a half k, or k over 2, and that equals 0. And clearly from this, k equals 30. Okay? Now for part B, we've got to find the other two roots of the equation. So first of all, let's just copy out what the equation is. So we've got that it's 2x cubed minus 9x squared plus, instead of k now, I'm just going to write 30x minus 13, and that equals 0. Now, in order to solve this, we need to factorize our cubic expression here on the left. And I know that x equals a half is a root of the equation, so that means one of the factors must be x minus a half. Well, rather than use x minus a half, I'm going to change that to 2x minus 1. We'll have 2x minus 1 multiplied now by a quadratic factor, and that will equal 0. And I can get this quadratic factor either by dividing 2x minus 1 into the cubic expression here, or I could just get it by observation. And I'm going to do it just by observation. It's got to be an x squared term here, so that we get 2x cubed when we multiply 2x with x squared. And I know for the constant at the end, if we've got minus 1 here and we've got to get minus 13, it must be that we multiply this with 13. The question is, what is the x term here? I'm just going to write plus bx in, okay? Now there's ways that we can get bx, and one way is to compare, say, the x terms. If I was to compare the x terms, I don't have to do that. I could compare, say, the x squared terms. I'll leave it to you if you want to try that. So if I look at the x terms, what are we going to get for that? We're going to have 2x multiplied with the 13 is going to give us 26x. And then we'd have minus 1 times the bx, which is going to give me minus bx. And that's the only x terms we're going to have, and that's got to come to 30x. That's got to equal then 30x. So clearly from this, b must be equal to minus 4. So try it with the x squared terms, comparing those, and you should find then that you get b to be minus 4. So that means that therefore, when it comes to factorizing our equation here, we're going to have 2x minus 1, and then that's going to be multiplied by the quadratic factor x squared minus 4x plus 13, and that equals 0. So if we've got to find the other two roots of the equation, we know that we get x equals a half from this one, but we need to solve the equation, the quadratic equation, x squared minus 4x plus 13 equals 0. Now this doesn't factorize easily, so we're going to use the quadratic formula where a is 1, b is minus 4, c is 13 then. So x would equal minus b, so that's going to be 4 plus or minus the square root of b squared, so it's going to be minus 4 all squared, minus 4 times a times c, which is 13. All of this is divided by 2a, 2 times 1, just leave that as 2 there. And cleaning this up, we've got 4 plus or minus, we've got 16 here, minus 52, which is going to be minus 36. So you've got the root of minus 36, and that's all divided by 2. Square root of minus 36, well, that's going to be plus or minus then 6i, I being the root of negative 1. And that's all over 2. And this breaks down to 4 divided by 2, which is 2, plus or minus 6 divided by 2, 3i. Okay, so there's our other two roots of the equation.